Let's get started then. So, quick roll call. We have Ananya, Anjika, Arya, Aryan, Dev, Chris, Neil, Rehan, Ritika, Sarah, and Sivatsap. And we have few kids missing. We will see how soon they are able to join. But yeah, we'll get started. Yeah.
Sir, I don't think Sarah is going to be in class today. I think she texted you that.
Say that again.
I think she texted you that she won't be in class.
Who?
Shravya.
Shravya. What did she? I remember having seen a message from Dhanushri, but was not sure about Shravya, but that's okay. We will get started. Oh, yeah. All right. So he is here. Okay. So a quick check. Till yesterday we were learning permutation and we just briefly touched upon what is combination at a concept level. So any questions so far? Anything that you find was not clear? Anything that was cryptic enough to be confused about? You guys just think about it and give me 10 seconds. I'll just get my water bottle. I missed that. Just one second. Okay, so anybody having any confusion or doubt with respect to what we have learned so far with respect to permutation? No doubts? Okay, I'll take that as a no and we'll get going. So, a summary of permutation is when you have few things to arrange, when the order among them matters, that is permutation. When you talk about combination, you're talking about distinct things in a group, but what doesn't matter is the order between them. So, if I'm talking about permutation, then these two are different things. If I'm talking about combination, these are all same. These are combination of ingredients where even if the orders are different, they are considered same. This is considered a group of three characters A, C and T. Whether you are jumbling them, whether you are keeping which one first, which one later, doesn't matter. This is called combination, this is called permutation. So now we have seen that if I have, let's say, three things to be arranged or organized, we can do that in factorial three ways. If I have five positions to be filled with, let's say, three things, or I have five things to fill three positions, then we call it 5 permutation 3, and then we saw the formula which says this equals factorial 5 or 5 factorial divided by 5 minus 3 factorial. This part we understood. In essence, it says that if you have 5 options and you have 3 positions to be filled, you can do this in 5 permutation 3, which translates into this formula. That's what we have seen, and how it is derived, that also we have seen, so I'm not going to that. But in essence, it says if you have 3 positions to be filled with 5 things, this is the number of options that you have, where the order among them matters. Now we are going to the next topic, which is combination. Let's look at, or let's try understanding that at a concept level first, and then we'll do a double click on that and see how that relates to what is called probability. Everybody with me so far?
Yes, sir.
Okay. So let's look at the alphabets. We all know that there are 26 alphabets. And if I say, how many words how many 3-letter words we can form with this, then you'll say, okay, I have 26 options and I'm talking about a 3-letter word. So this will be 26 permutation 3, which results into factorial of 26 divided by factorial of 26 minus 3. And this will translate into factorial of 26 divided by 26 minus 3 is 23, factorial of 23, which equals, we can say 26 into 25 into 24 multiplied by factorial 23. We just split this, okay? Divide by factorial 23, and this turns into this many options. So if you have to form a 3-letter word with including all the alphabets without repeating any of the letters, any of the alphabet, you can have this many words. Whether they all have meaning or not, that's a different point. So this is permutation. Now, if I say, how many 3-letter words you can form, or let's say how many 4-letter words you can form with all the alphabets without repeating any of the alphabets. Meaning, I'm talking about a situation where I have 26 alphabets to choose from, and I'm talking about 4-letter words, and I'm saying how many of 4-letter words you can form without repeating the alphabets. Meaning, I'm talking about things like, let's say, I don't know whether this is a word or not, and I don't want to care about it also right now. I'm talking about this word, but I'm certainly not open to this option. Meaning, I'm not wanting to repeat the alphabets. And also, another thing that I want to do is, I don't want to really care about this and this being different. For me, it's a 4-letter word. And this is a classic example of a combination, where you're trying to see how many combinations of 4 characters you can derive by using 26 of the alphabets. So you can have, this is another combination. Now, how you want to jumble them, that is not relevant here. This is another combination. You can jumble them, but how many of such unique combinations of characters you can form? That is what is called combination. Now, you will say that I know that if I have to form a 4-letter word, the permutation way, my options are this. This will be my result if I have to figure out how many 4-letter words I can form out of 26 alphabets. So this will be factorial of 26 divided by 26 minus 4 factorial. This will be my answer. But then this includes, let's take A, B, C, D as one group of 4 alphabets. This is one word. This is another word. This is another word. This is another word. And there could be many more. So, all the words that I can form by jumbling them or by kind of doing some mix and match among them by changing their orders, all that has to be considered as one, because we are not interested here in figuring out whether ABCD is one word or BACD is one word. We are saying, okay, how many unique combinations of ABCD or likewise other alphabets can be derived from this. That means you certainly want to, this is your total number of words that you can form where the order matters. But if you don't want to consider these being different, then this is going to be less than this. How much less? That is what we are going to find out, and that will be our combination. So, first of all, I want to understand whatever I have said with respect to the difference between permutation and combination, is that part clear to you all?
Yes, sir.
Okay.
But also I have a question.
Mhm.
Let's say there's a problem that's asking you to find this. Let's say you have to find a 4-letter word, and then the order does matter, but you can't repeat the letters.
That is simple case of permutation.
No, but you can't repeat the letters. Then
You can't repeat the letters, but that is still a case of permutation. Let's take a simpler example. Okay, let me not go to 4. Let's go to 3. So that way we can look at the real examples. Okay. Sorry if I cut you in between. You're saying that I have 26 alphabets and I have to form a 3-letter word. That's fine.
Yes.
Yeah. Now, here you're saying you cannot repeat them. That means you can have a word like this, and you can have a word like this, but you cannot have a word like this.
yes.
Yeah. That's a classic case of permutation, because when you talk about permutation, what you're saying is you essentially have 3 boxes that you are trying to fill with 26 of them.
Mm-hmm.
When you try filling the first box, you have 26 options.
Yes.
When you try to fill the second box, you have only 25 options because you have chosen one of the options for the first box.
Mm-hmm.
So you are left with 25 options. Then when you go to the third box, you are left with 24 options because you have chosen one of the options here and one of the options here. Why it is 24? Because you are not wanting to consider something that is already used in this box or this box.
Okay.
So that means you are not repeating your words.
Okay.
Had it been a scenario where you had the option of repeating the words, then this would have been much simpler ask. Say, okay, fine. Meaning, I can pick any of the 26 options for filling the first box. And my situation remains the same for this case also, because I have not been given any constraint with respect to what I can choose versus what I cannot. Yeah? So that would have been a different situation, because you don't have a constraint, the sky's the limit. Yeah?
Yes, sir.
So that is why when we talk about non-repeat scenario, that is where it is permutation. This is not permutation, this is repeating. Yeah? Hey, Vaibhav. So now, yep. So Vaibhav, we are just continuing from where we had left it yesterday. So we just talked about permutation, and then we are talking about the next topic, which is combination. And then we'll go to how do we relate our understanding of permutation combination to deal with probability. Yeah. Anybody in the class who is having any doubt or question with respect to what we have discussed so far, please feel free to ask. Anjika, Ananya, Aryan, anybody, okay? And okay. So Anjika disconnected, she will join back. Alright, so now coming back to the same situation. Okay, we have 26 alphabets, we are trying to form a 3-letter word. Meaning, when the order matters, we know that it's a simple case of permutation. 26 options, 3 positions, that translates into 26 factorial divided by 26 minus 3 factorial. This part is okay. Here, meaning ACT and TAC, CAT, ATC. How many ways we can arrange that? ACT, TAC, CAT, CTA, and TSC, TCA. This option basically trying to form the words, these matter because we are talking about permutation, meaning every position, who is filling what position matters. That is what is a classic case of permutation. Now if I say that if these things don't matter, meaning I don't want to worry about the ordering between the letters. What I'm only concerned about is there should not be a repeat of A or C or T. As long as A, C, T, is concerned, I'm treating this as one piece regardless of their positioning in the three-letter word. This is called combination. So, likewise, how many such combination of three characters can be formed with 26 alphabets? That is what will be called a combination. Now, how would that translate into a formula? If I would have looked at permutation alone, meaning every order, every sequence matters, then that would have been this. But we are trying to discount the internal jumbling of the characters here, meaning whatever we got by due to the whatever number we got due to rearranging them, that has to be eliminated. Meaning every such, let's say you pick PAT as one combination. Likewise, you will have PAT, PTA, APT, ATP, TAP, TPA. 6 words. You don't want to count them all together. I mean, you just want to treat them as one. Meaning, whatever count you are getting, you have to divide that by 6 for every combination of 3 characters. That will give you the number of combinations that you're talking about. Meaning, again, a combination is like, let's say there are 10 kids in the class. I want to create group of 3 kids each, regardless of who comes first, who comes second, who comes third in that group. That is combination, which is different from permutation. In case of permutation, it matters whether who is my first kid, who is the second kid, who is the third kid. Wherein in case of combination, first, second, third doesn't matter. As long as you have 3 unique kids identified, that is enough. So in case of permutation, the order matters. In case of combination, this is a smaller number, meaning the ordering between them you are going to split. So if I represent this as combination, if I say 26, 3, what I'm talking about is whatever is my value of permutation, whatever is my value coming from permutation, I'm going to divide that by number that is coming into play by ordering these among themselves. Meaning here I had 3 characters, I got 6 options. If I had 4 characters, I would have got factorial 4 options. See, 3 characters, factorial 3. 3 things you can arrange in factorial 3 ways. That is how it's resulting into 6 options. If I had 4 characters, that would have been factorial 4, meaning we could have arranged those 4 characters among themselves by reordering them in factorial 4 ways. That means, in this scenario, my number of combinations or number of unique combination of 3 characters would be this divided by factorial 3. Now I know I purposefully got you guys confused. Let me see if I was successful or not. So this is the difference between permutation and combination. Let me just do a recap of what I said. If I'm talking about permutation, meaning I have certain options to choose from to fill certain positions, this gives me the number of options I have where I'm sensitive about the order in which they are placed. Wherein if I'm just looking at the number of combinations, a unique combination of 3 characters, this is what my answer would be, because I'm knocking off every 3 characters which can be arranged in 6 ways. I'm treating them as one, and that is how I'm dividing that by number of count that increases by ordering them. So my combination formula becomes like this. This is factorial 26 divided by factorial 26 minus 3 into this thing, factorial 3. So if you see the difference between permutation and combination, you see when you are talking about combination, the ordering part you are ruling out, and that is where you end up dividing that by the number of ways in which they can be arranged or organized. So this is permutation where the order matters. This is combination where the order doesn't matter. It's just the unique combination matters. Now, let me stop here. A moment of silence to understand if there is something that is not clear yet. And there is no harm in being confused because your teacher might not be very clear all the time. Any questions here? Anything that is not clear or difficult or cryptic to understand? No questions? I cannot be that good a teacher. Let me check one by one. Anjika, Rehan, are you clear?
Yeah, I get it.
You got it? Okay. Chris, Dave. Okay. Got it. Okay. Okay. Neil, Sarah.
Understand.
You understood? Okay. Very nice. Oh, that means I'm a decent teacher. Cool. That gives me a lot of confidence. Aryan, are you clear, beta?
Yeah, sir.
Okay. Yeah, that makes me proud for myself. I'm doing a good job. Okay, cool. Jokes apart. Coming back to the serious topic. So, a summary of this is there'll be many examples that will come to. We'll talk about that and then we'll try relating that. But in summary, if you're talking about permutation, meaning you are utterly serious and sensitive about the way things are organized, that is when it is called permutation. Meaning, the generic formula for permutation would be, I have n options to fill k positions. My formula for this would be factorial n divided by factorial n minus k. Yep. So what's up, Vaibhav, with me?
Yes.
And if I have to find out unique combinations. So again, now let's go back to English rather than being worried about maths. When you're talking about combinations, you are saying that okay, combination of 3 kids. If I ever say from this class I will form a combination of 4 kids to make groups, you can simply assume that I'm talking about combination of 4 kids. It could be Dev, Chris, Srivatsav and Sarah as one group. Doesn't matter whether I'm calling out Dev's name first or I'm calling out Sarah's name first or Chris's name first. My second combination could be Rehan, Shravya, Ritika and Arya. But I'm just worried about the 4 names, 4 unique names. I'm not really worried about whose name I'm putting in the beginning or whose name is coming in the end in the group, right? So that's where the combination is just a combination of things regardless of the ordering among them. Yeah. So my formula for permutation becomes like this, and my formula for combination becomes like this: factorial n divided by factorial n minus k, which is the permutation part of it, and whatever number of positions I'm going to fill, I'm knocking off the way they can be organized among themselves, which is always factorial of that. So these are the 2 formulas that we have seen how it comes into light, how it comes into existence when we are dealing with some practical problems. Okay. Now, I don't know how many of you play cards. I was not supposed to play cards when I was your age back in India, but those were like ancient times. Nowadays, it's not considered a bad thing as long as you're not doing it for a wrong reason. So, you all would have played Uno or regular cards. Now let's look at a practical example. If you're looking at a pack of cards, it essentially has 52 cards. Okay, so 30 of each type, right? They are called diamonds, spades, and I forgot. What are the other two types? Diamonds, spades, yeah?
Clover and hearts.
Club and hearts, yeah. So, yeah. So, we have 13 cards of each type. Now, let's say we have 6 people playing the card. Or, in how many ways we can distribute 9 cards to all these people? Regardless of how many people are playing, let's say if I have to distribute 9 cards to all the players playing this game, how many ways I can form group of 9 cards? So I have 52 cards. I want to distribute 9 cards each to all the players. Obviously it will be less than 9, 6 or 54, so less than 6 people. So what will be the number of people? If I have to distribute 9 cards each, how many ways I can distribute the cards to these people? I know I have not solved this problem. We just talked about permutation, we just talked about combination. And I'm saying, in how many ways you can distribute 9 cards each to the player? Or how many groups of 9 cards, in how many ways you can create a group of 9 cards for distributing it among the players. So, before we try solving it, a question to you all would be, are we talking about a permutation scenario or are we talking about a combination scenario, and why? I'm repeating the question one more time. So there are 52 cards in a pack of cards. We want to distribute 9 cards each to all the players playing the game. And let's assume that obviously number of players is less than the number of cards needed. So I'm not wanting to worry about whether it's 2 players or 4 players. I'm just saying I want to create a group of 9 cards. How many such groups we can create with a pack of 52 cards for 9 cards each? So is it a permutation scenario? Is it a combination scenario, and why? Anybody? Yes, Ritika.
So I think it's a combination scenario because it doesn't matter if the person gets a clover, heart, or diamond, or spade.
Or which one first types, right?
Yeah, it doesn't matter what cards they get. They just need to get in groups. They just need cards.
Yeah, okay. That's one perspective. Anybody having a similar point of view, different point of view, not being clear with the question, please feel free to ask. Trace, Dave, anybody? Arya, anybody? See what's up?
No questions.
No questions. So it's a very, yeah.
So I have the same perspective.
Same perspective. Yeah, so it's very simple. I'm saying that I have 52 cards. Maybe there are three people, 3 players, 4 players, doesn't matter. My intention is to create a group of 9 cards so that I can distribute among people. And I'm just trying to find out how many ways I can create a group of 9 cards. Whether when somebody gets those 9 cards, which one is first, second, third, fourth, doesn't matter, because that the players will arrange by themselves. The person who is distributing it doesn't really have to worry about it. So we are talking about essentially the combination scenario where I'm just creating a group of 9 cards, that's it. Nothing more than that. Yeah? And then how do you solve it? So what the answer would be? Yes, Chris.
I just tried applying the formula you gave us. I got 52 factorial over 9 factorial times 43 factorial.
Yeah. So you guys are more intelligent than me for sure. I am less intelligent, so I will still go step by step. I'll say 52 factorial divided by 9 factorial multiplied by 52 minus 9 factorial. So this fits the formula. And then we all know how to do calculation, right? Because I will always insist or prescribe you guys to solve the sum like you are telling a story. Okay? Meaning, you would have seen whenever I am trying to solve a problem, right? What do? Okay, this is, I have 52 cards, I have to create a group of 9 cards each. What do? This is a combination scenario. My combination scenario says this, which means factorial n divided by factorial n minus k multiplied by factorial k. Here n is 52, k is 9. So this becomes 52 factorial divided by 52 minus 9 factorial multiplied by 9 factorial. And then obviously then we know what to do with this, right? So I know this might be a little cumbersome, but the advantage with this is when you're doing the scratch work, doing things in a stressful scenario, there is a likelihood that you might go wrong. I mean, those are called human errors. So whenever you finish solving a problem, you would always want to get into the habit of reviewing them, because it's easy to go wrong. So when you're reviewing them, if you have the story written here in front of you, then you would know if my answer is not matching or it's not matching with one of the 4 options that is given. Oh, I missed this one. Then you will correct and then proceed further. But if you are going a little too fast, it might be difficult to figure out where you actually went wrong. Yeah. All right. Now let's take a few problems to solve. So what we'll do is, I'll pick up some sample questions from what I was kind of preparing for you guys. So okay. Now let's solve one problem before we jump into probability scenario. Okay. Now let's say in a class of 30 students, we are being given the task to form group of 6 students each for a science research or science exhibition. How many such groups we can form? So in a class of 30, we are being given the task to find group of 6 students each who are going to participate in the science exhibition. How many ways we can form the group? And okay, yeah, Ritika.
Oh, I don't know the second part of the question.
Second part of the question also. I would not give that easy a question to all my intelligent students, right? I would want to trick you guys. And the first position has to be fixed. I mean, you have 6 positions to be filled. What I'm saying is, so you are making a group of 6 students, and the first position has to be filled by a predefined rank holder who is from 1st to 6th. So basically what I'm saying is, from 30 students, with a class of 30 students, you have 6 rank holders, 1 to 6. You have to form group of 6 students for doing science research, where the first position has to be filled by always a rank holder, and the same person cannot be in the obviously. So let's not talk about a repeat of anything. I'm saying that you have to form a group of 6 students for doing this science exhibition. You have to find out how many ways you can form the group, wherein the first position, the team leader has to be one among the rank holders. And I want to see how you guys would want to approach it. So let me repeat the question one more time. You have 30 students in the class. You have been given the task to form a group of 6 students each to participate in the science exhibition. You have to find out a number of groups you can form, and you have to also make sure that the first position or the team leader for every group is one among the rank holders, who is 1 to 6. Yeah? Let's see how you guys are approaching it. And we have 10 minutes to solve this, not 10 minutes, 5 minutes to solve this problem. At least get to an approach. So think about it and come up with the approach before you try solving it. I hope everybody is trying to solve it, right? Chris, Dave, Shivatsav, Sarah, Neil, Aryan, Arya, everybody is trying to solve it, right? Everybody heard the question correct?
Yes, sir.
Yeah.
Okay, okay. Yeah. Anjika, you're trying as well?
Yeah, I got it.
Okay. Let's see. What is that we are getting to? Yep, Ritika.
I didn't really put the numbers in the calculator and solve it. I just want to know if what I'm thinking is right. So you have 30 students and then you have 6 groups. And then I drew out the boxes for the 6 groups and then I only do permutation for 6 people and then combination for 24 people.
Yeah, that makes complete sense, but I would want you to not to assume that your teacher is intelligent. You have to explain that to me in a layman's term.
Let's say you have groups of 6 and each group has 6 people in it, and then you know that the order only matters for which ranked kid goes into the group. You don't care about the rest 5 positions. So they can be in any combination. So that's where the combination comes in.
Yeah.
But then the permutation is for the 6 people who go into the 6 groups, because you can't repeat the person, or you can't. They have to go in a certain order.
Yeah.
And then you add both of them, and then you'll have the amount of probability, right?
Right. Yeah. So I'll not be adding them, but yeah, I think you are thinking in the right direction. So I'll still give you the benefit of doubt, and let's see what is the other input coming from the class.
Okay.
Anybody else? And see again, I have kept the option open for each one of you by saying that I'm giving Ritika the benefit of doubt. That means I'm not saying that whatever Ritika did is 100% right. She might be right. I'm just letting you guys explore your own self and tell me, because there could be 100 different ways to solve one problem, okay? And for all of us, for this group, I want to pick up the best and the easiest one so that it stays with most of you. Anybody? See, I like the way Ritika explained this, right? Because she said, I'm not wanting to worry about how to solve it. I'm telling you what is my approach, what is the thought process, and that is what is worth $1 million. Because if you are thinking the right direction, solving problem is going to be a cakewalk. So that's why I would want you all to put your energy and effort in getting the right approach. Problem solving is kids play, okay? That would not be something that I would really want to worry about. If your approach is, if you are clear about the approach, you can do magic. So that's why I want to hear the approach from many of you. I don't know why everybody is quiet. I'm not sure if I'm kind of stressing you guys out, but I certainly don't want you guys to be quiet. Rehan, Sarah, any thoughts? Say what's up, Vaibhav. Okay. So I know this is a concept that we have learned just recently, and you might not be finding it very comforting to begin with. So and that comfort will come with practice only. Okay. So you all will have to promise me that you will do the unit test of Khan Academy for this particular one. Go to Khan Academy, search for permutation, combination, probability. It will open up a unit for you, and then in that you have to do unit test. Now look at this. I will not try solving this problem, okay? But I will give you guys the approach. So the question says there are 30 students in the class, and there are 6 ranked students, meaning rank 1, 2, 3, 4, 5, 6. Okay? We are trying to form a group of 6 kids for the science exhibition, and the only condition is that every group should have one of the ranked person in the group. So that means, let's say if I'm talking about filling up 6 boxes, I've been told that 6 boxes already reserved, and this can be filled by only ranked people. So essentially, out of 30 students, we have taken out 6. We are left with only 24 to choose from to form the combination. Yeah? So this is the combination part that Ritika is talking about. Meaning, we have to find out different unique combination of 5 students from a group of 24. So this becomes 24C5. This takes care of filling 5 boxes for every group. What we are left with is the 6th box. Now, 6th box meaning 6th position. This one position has to be filled by one of the 6 kids. Meaning, you can fill this in 6 kids to fill one position. This is a permutation scenario. I mean, while this doesn't matter here, I mean, you have to fill one position with 6 kids. You can do that in factorial 6 ways. Not factorial 6 ways. It'll be, yeah.
This was 0 factorial, so it was 1.
Yeah. Which one?
Instead of 1, it would be 0.
Why 0?
Oh, no, 6. It'll be 6.
It will be 6. It will be 6. And you look at this like a permutation scenario. You have 6 positions, 6 people to fill one position. How many ways you can fill that? Right? So this will become factorial 6 divided by factorial 6 minus 1, which eventually becomes 6. So this value multiplied by this value 6, that is what it will give you. Or in simpler terms, I mean, even if you don't want to think of this as a permutation scenario, you will say, okay, fine, 5 positions are filled with the combination scenario. We can create a group of 5 in this way out of 24, and then the first position has 6 options, so it can be filled in 6 different ways. You can pick first one, second one, third one, fourth one, fifth one, or sixth one. You have 6 options, so multiply that by 6. I mean, whether you look at this as a permutation case or a 6 option to choose from, both are the same. So this becomes 6 times this. This becomes your answer. How much that is, we are not going to solve it. I was just wanting to confirm that you guys got the approach right. Now, whatever Ritika talked about or whatever I tried explaining, did that make sense to all of us, or we have an opportunity to go back to it again? Yes, Ritika.
The thing is, for permutation, I was trying to find 6 people to fill in 6 positions, not 1 position.
No, so you did not have to do that, because you have, see, it's like you have 6 boxes to fill, 5 boxes you know how to fill. 6th one, you have to just fill by one of these. So basically, you're trying to fill one position with 6 options. So that is 6 permutation 1. Yeah.
But what about the other 5 people? I try to visualize it like the first group is on the top, the second group is at the bottom, and then third group, fourth group, fifth group, and sixth group. And then the first boxes are all unfilled, so I had 6 people to fill in 6 positions.
I don't think I understood that. I'll probably come back to you. Let me hear what Anjika has to say. I'll come back to you, Ritika, again. Yeah, Anjika.
I was just confused about why you would multiply it and not add it together.
Okay, so we'll do that. So this is where permutation, combination are easier concepts, but it gets confusing at times depending on how we look at it. So I'll come back to it. Okay, so let me go back to it one more time. But Ritika, what was your point? Just help me understand that once before I start doing my circus.
So there's 6 boxes. You draw 6 boxes. In the first, no, make it small because you have to draw 6 boxes 6 times.
Why 6 times?
Because there's 6 groups.
I'm not wanting to even talk about it, because see, I'm saying with 30 students, we have to form a group of 6 students. I never said 6 groups, because that is what is going to be a combination count.
Oh, okay, yes.
Yeah?
Okay.
Clear, right? I mean, see, I have some very, what you call, raw method of sometimes convincing you guys, but I hope I'm making sense so far, right?
Yes.
So, the question says, I have 30 students in a class. I want to form a group of 6 kids. Depending on how many we want to, whatever be the number of possibilities. I mean, that is out of question right now. We have been asked to find out how many such groups we can form, or how many different combinations we can form with 30 students.
Yes, sir.
Yeah. So Anjika, now let me kind of try explaining that not only for you. I know some of you who are keeping quiet might have similar doubts. So this is something that I had learned during my probably 15th year of the career. Something called design thinking, and design thinking means that's a new concept which says that we should focus on finding the problem first, understanding the problem first, defining the problem first. Once you define the problem, understand the problem, solving it is not a big deal. Okay, so that's what we'll do. So first thing is, the question says you have a class of 30 students, no doubt, right? Simple, one liner. There is a class where we have 30 students. Fine? Everybody okay with me? Okay with what I said? Okay. Now, it says find out how many combination of 6 students, how many group of 6 students you can form with these many kids to participate in a science exhibition. Okay? So there are 30 students in the class. We have been asked to find out how many groups we can, or in how many ways we can find or form groups of 6 students each to participate in a science exhibition. Yeah? And I see some kids are joining early. Okay. So kids from the next class, stay back for 5 more minutes. Now, 30 students we have in the class. We have to form as many groups possible of 6 students each. And the only condition we are given is that every group should have one of the ranked kids. From 1 to 6, every group. So there are 6 kids who are ranked 1 to 6, okay? Every group that you are forming must have one and only one of the ranked kids. So essentially what we are saying is, we have 6, every group will have these 6 boxes. And we have to find out how many such group of boxes we can form. And we have been told that this position has to be filled by one of these 6 kids. Meaning, you are left with only 5 positions to be filled. Meaning, you have to form different combination of 5 kids out of this group by taking out this. Okay? So you have total 30 students. You have taken out 6 of them. So you are left with 24 kids who are not ranked. And out of 24, you have to find out different combination of 5 each. Give me 5 minutes. So out of the 30 kids, 6 ranked kids are taken out, who will fill one of the first position in every group, and remaining 5 slots are to be filled with these 24 kids, and you have to find out the number of combinations. So this is where it becomes a classic case of combination, which we learned that okay, we have to fill use 24 kids to fill those 5 positions. So that takes care of the number of combinations we can have. Now, what we are talking about is what happens to the first position. First position is to be chosen from this, meaning this box can be filled in 6 ways. You can fill this box by 1 or by 2 or by 3, by 4, by 5, by 6. So after you form the groups, every group, whatever is the total number of groups that you have formed, that can be multiplied by 6 to give you the total count of groups that you will have. Am I making sense so far?
Yes, sir.
Yep. Anjika, was it clear, beta? Oops. Was it clear for everybody else? Neil, Sarah, here? Yeah? Okay. Yes, Chris.
I understood the part where you said about like the 24 combination 5, but why do you multiply it by 6?
Because now imagine this, if you had only 5 positions to fill and you form, let's say, 200 groups. Now when you are filling the first one, for every one you have this many groups, right? It's like you are repeating yourself. So you have to fill 6 positions, right? So this whole combination, let's say you got, let's say, 1, no, not 2, 4, 5, 6, no, not 4, 5, 6. Let's say 7, 8, 9, 10, and 11. These are the 5 kids that you picked up for the 5 positions. Now, this same group can repeat 6 times. One time with 1 in the first place, one time with 2 in the first place, one time with 3 in the first place, one time with 4 in the first place. So every group that you have 6 more options because the first position can be filled in 6 ways. Yeah, Ritika.
I understood what you said, but let's say hypothetically, you can form 25 combinations with 24 people. I'm just using a smaller number because I don't know the actual number. But let's say for the first ranked kid, you have this many options. You have 25 options of 5 students.
Yeah.
Groups of 5 students to choose from.
Yeah.
But then for the next kid, you would have 1 less than this first student.
No, not really. What is happening here is you have so many groups formed already. Now, number 1 can tag along with any of those groups.
Yes.
Number 2 also can tag along with any of those groups because these people are not common here in these groups.
Yes. But you can't, 1 person can't have the same group, right? 2 people can have the same group. So let's say the first person picks a group of, right? And then the next person should not pick that group.
Next person can still pick the, see, so we are talking about combination, we are not talking about permutation right now.
Yes.
So look at this being one group now with 1 and these are exclusions, so these are not part of any other group. When you pick second one, then this group can still repeat because it is still a unique combination. One time it is unique combination with 1, next time it is unique combination with 2, next time it will be unique combination with 3 also.
I sort of understand.
Okay, so yeah, I know we are at top of the hour already, and the younger ones will get scared if I keep talking about permutation and combination. But whatever the request you guys is, whatever we have talked about so far, spend watch the video, towards last 15-20 minutes of the class at least, and see if I am myself confused or I am getting you guys confused. And then depending on what the conclusion is, we will take this discussion in the next class. Okay? So what we'll do is, we just talked about the concepts of combination, we understood permutation, but we have not touched upon how these two relate with the probability aspect of it. Okay? So probability, when we talk about number of occurrence for the given scenario versus the overall number of occurrence, right? That's what is probability. But we'll go to the concepts and we'll do more sums before we try doing more practice on this one. So try spending some time to brush up the concepts on combination, and then we will try clearing the dust in the following class. Yeah. All right.